everyone! We are on Chapter 1, Learning Target 6. This is Miss Oshier.
And Miss LaHart.
And here we go. So remainder and factor theorems. It's going to be a really quick one.
Yep.
So using the beautiful synthetic division or substitution method, you can determine whether or not something is going to have a remainder. So for instance, if I wanted to know if I divided this big old thing by x minus 5, would there be a remainder? What would it be? So you can either plug 5 in, because remember you're going to plug the root in, not the factor, and get 29. That's your remainder right there.
Mm-hmm. That's the remainder theorem.
Or you can synthetically divide that bad boy, and that last number, as we know, is the remainder.
Mm-hmm.
You choose which method you would like.
Yes. Well, we'll be very specific on which one we want you to show us. If we say the remainder theorem is, if we say synthetic, you know. Yada,
Absolutely.
yada, yada.
But remainder theorem just means what's the remainder.
Plug it in, plug it in.
Some of you will long divide it and take a long time, and that's fine. That's up to you.
Well, yeah.
Okay, factor theorem is even easier. Basically, if there isn't a remainder, it is a factor. If there is a remainder, it's not a factor.
Yep.
So if you plug it in and you get 0, that means no remainder, so it must be a factor. If you plug it in and you get a number, you know, well, that's a remainder, so it isn't. Also, remember, here are your zeros, so that's what it's telling us. It's telling us that it's a 0 on the graph.
And so it's a factor.
Again, if you have no remainder, it must be a factor. That's all that says.
Mm-hmm.
Boom, boom, boom. Okay, and then just one thing that we wanted to show you really quick. For this graph, we can determine that the factors are x plus 4, x minus 1, and x minus 3. But then we also have this y-intercept. So where that comes into play with the equation as we start getting more specific with things is that you're going to have a leading coefficient. Mm-hmm. So if you were to plug in for x 0, because your y-intercept is 0, 3, you're going to get an a value. Mm-hmm. So you're going to get 1/4 a. So you could rewrite this equation like this. So you have factors, and you can also have a leading coefficient. But for the remainder theorem, or excuse me, the factor theorem, all it would say is that if you were to plug in any -4, 1, or 3 into this equation, it's going to give you 0.
Mm-hmm.
Okay. So this is kind of going further than the factor theorem actually is. So if this just confused you, we're just kind of showing you a little bit more right
We'll
now.
get into it more.
Yeah.
All right, so use the factor theorem to determine whether the function, yada, 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 is a factor. So is x plus 1 a factor of that wonderful looking?
Right. I think I stopped typing here. Sorry. Like,
Line
are
on you.
these factors of that guy? So -1, plug it in. You get 0. Is it a factor?
Yes, it's a factor because
Woo!
it does not have a remainder.
All right. Let's plug 1 in because remember you're plugging the root in. I get 4. Is it a factor?
No.
No. 'cause
No
it's got a
factor.
remainder.
It's got a remainder.
It's that simple, everybody. Don't worry about sketching a graph. We're going to be doing that later. That is it. Have a wonderful day.
Peace.